This is, we're going to start with some basic stuff. Automotive electronics test 1. Most vehicle manufacturers today do not network their electrical systems through computers. Is that true or is that false?
False.
Okay, you know what networking is, right? Whenever you plug a scan tool into the data link underneath the dash, how is your scan tool getting that information? Anybody know? Sir? Well, that's a fairly intelligent answer, but what they basically got either 1 or 2 wires depending on the network, and all of that stuff, it comes in little bursts of digital voltage, and it knows how to sort that stuff out, and it turns it into the numbers that you see on the scan tool screen. And your modules, the ones from in different parts of the car, they talk the same way that the scan tool talks. You know, when you plug the scan tool in, basically it's a window into the system. Back when Chrysler first came out with their Star Scan, it was pretty cool. When you plug the Star Scan in, it would boot up and it would give you a map of the vehicle network, and it would show you all the modules, which ones were connected to which other modules, and which ones were in little sub-networks and all that. Okay, you got that map on your screen. You would touch the screen of the module you were, let's say that came in for an ABS light. You look at that, you pull it up, it's showing you all your modules. You tap your controller anti-lock brake, which Chrysler called a cab. Punch that thing, whoop, it comes up. Then you tell it what you want to do. You want to read codes, you want to look at inputs and outputs, whatever. See, all these computers use inputs and outputs, just like this keyboard and mouse and monitor. Their inputs and outputs are slightly different, though. You know, they're going to be looking at temperatures and movement and speeds of different components and all that kind of thing. And let's say that you've got wheel speed sensors for your anti-lock brake system, right? It's already reading wheel speed. And the anti-lock brake computer is basically able to work with that wheel speed. And hey, James, what you got there?
I was just going.
How'd you do? All right, that's not too terribly bad. Okay. Well, all right. Put that in your box. I'll ever file that and everything. And right now I'm giving a lecture in here, so lay low. Okay. All right. But anyway, what I was getting at was we've got this situation that we're looking at. We've got wheel speeds. We know what the wheel speeds are, right? And if we need to know, what else needs to know vehicle speed besides your anti-lock brake system? What else is it? What else needs to know it? Speedometer needs to know it, doesn't it? Cruise control needs to know it. Engine controller needs to know it if it's controlling the transmission shift points. So why can't we just take the anti-lock brake and, the anti-lock brake module, and let's farm that, or harvest, I'll say, that signal from the ABS, and we will be able to use it on everything else that needs to know vehicle speed. Wouldn't that be good? All right, if you do it the other way, you got to have a different sensor for every module reading the same doggone thing. See why how important networking is? And it's not that complicated, really. Number 2, a neutral safety switch is used on vehicles with automatic transmissions. Will your car start if it's not in park or neutral? Will your car start if you don't have it in park or neutral? I'm talking about spin the keys, start the engine.
No, they'll start.
If you put it in reverse and you try to start it within reverse, it's not going to start, is it? No. Okay, so that's a no-brainer of an answer. No, don't play dumb with me. All right, a charging system is used to restore to the... See, these are really basic questions. So I want you guys to start thinking about them. The questions will get more complicated as we go through the semester. A charging system is used to restore the battery to the battery the electrical power used during engine starting. Is that true or is that false? Your car wouldn't start at the Chevron, right?
Yeah.
Okay, so what were you having to, in order to start it, the battery has got to be able to deliver voltage to the starter. And you're thinking maybe your battery, did his battery cable look dirty enough to keep that car from starting?
Yeah.
They did? You think that's what his problem is?
Maybe.
You think he needs to take care of that?
Yeah.
All right then. He'll be dead in the water again. He'll be out there, trying to start it and it won't start. Now, let me ask you this, did the lights come on, and then when you went to start it, they went out? I'm talking about the lights on the dash and everything?
Yeah.
That means you're down a battery cable is dirty battery cables. If the lights come on nice and bright on your dash, and you go to start it and they go out and don't come back on, or they come on real dim, that typically means you got dirty battery terminal. That's a good thing because you can clean those, right? You don't have to buy anything, hopefully, unless the battery terminals are all butchered up. Okay, let's see. Charging system is used to restore to the battery electrical power. Alternator does that, right? The vehicle lighting system only includes the lights on the exterior of the vehicle. Where all do you have lights?
Let me see, on your vehicle, back of your vehicle, and in your car.
Inside the car, on the dash, outside, front, back.
And
Where
in the
else?
compartment.
In the trunk, in the glove compartment. The one in the trunk and the glove compartment is the one that if it's on and you don't know it, can kill your battery, right? All right. So number 4 would obviously be false. Now the vehicle instrumentation system monitor various vehicle operating systems. And what is your dash going to tell? What's your dashboard going to tell you? What do you see when you're looking at your dashboard?
Your speed, the temperature, how much gas you have in your vehicle, and I think hot and cold water set temperature in it, so.
Yeah, engine temperature. Some of them give you transmission temperature. Have you ever seen a vehicle with a light on it that looks like a wrench? You got one, don't you?
Yeah.
Yeah, on your Power Stroke.
Yeah.
And have you ever seen a wrench light? You'll see a light that looks like a wrench on there. You ever seen one that looks like a gear with an exclamation point in the middle of it? What would you think that would mean?
Transmission probably.
Yeah, it's pretty smart. Transmission problem.
Mine does that, like when I was on my way back from Panama City, it was because of the gas or something, the diesel in it or something.
You mean the wrench light?
Yeah.
Yeah,
It's the only time it done that to me.
yeah.
I guess like, I don't know, like for some reason, like it had water in there.
Did it shake you up?
Yeah.
Yeah, the horizontal fuel conditioning module on yours, and when it gets water in it, it actually will ground a circuit that will, tell the computer to turn that light on. And I'll tell you something else too, in these electronic systems. These indicator lights on the dash are peculiar because the instrument clusters in a lot of cases are computers. They actually have a computer. Brian, stand up and let me see that instrument cluster right there. See that instrument cluster? Stand up. Stand up. Give me that. Turn it. Look at that instrument cluster. Turn it around. All right. Now turn it up this way. I mean, so that I can see the bottom of it. No, I mean, there. See where the connectors plug in and all that? Now, not every one of those instrument lights on that particular cluster is directly turned on by a switch. A lot of them will be the body computer will actually take input. You can put it back over there. The body computer will take input from the various things and will request. Like for instance, whenever you know how to brighten dim your headlights? Click, click. Okay, on some vehicles, and it's getting more and more prevalent, that switch is not sending a signal. In other words, the power that's going to the lights doesn't go through the switch. It goes to the relays down there, and the body computer operates the relays. And when you pull that switch, you're asking the body computer to give you bright lights. So you ask the body computer to give you bright headlights, and then when the body computer has done that, the body computer then sends a signal to the instrument cluster and says, "Can I please have a high beam indicator?" Now, years gone by, when I first started working on cars, the current actually flew through, the dimmer switch on the way to the headlights. You would turn on the headlights, the power would come to the headlight switch, go to the dimmer switch, and then it could either go to the bright or the dim side of the headlights. And tied into the bright side of the headlights, you would actually have the high beam indicator would come on. And,
You know that Ford we had here last semester, the black one?
yeah,
I had to put the accumulator on?
yeah.
How come the bright light switch was on the floor? You had to do it with your foot?
That's because the way they used to be.
Uh,
Yeah, that's how they used to be a long time ago. That Bronco we got is like that. It's got a dimmer switch on the floor. Did you know that there used to be a pedal on the floor to start the truck? They had a big starter button on the floor to the right of the gas pedal back in the 50s. You'd have to push that thing. You'd have to tap your gas a little bit and pull your choke, and you'd mash that pedal with your foot, and that would engage the starter. But you had to have the key switched on, and that was but yeah, that's just, you're looking into the past. You know, you need to go back to the future. You know what I'm saying? But that's what they used to do. They got 3 terminals on that switch. If you look at it, I've got one of them switches out here that we had to change out on one. Power coming in, power going out to dim, power going out to bright. And that was a good question, Quincy. All right, so let me see. Power mirrors are considered an electrical accessory. Your car got power mirrors on it? The outside mirror.
Oh, yeah.
Yeah. You know of a car that's got power mirrors on it?
Yeah.
Your mom's car? Okay, what about you? Your truck got power mirrors on it? He's a sorry dog. He's got a nicer truck than I do. My truck ain't got power windows on it. What about your car? The Kia? You got? It does? Okay. How many motors does it take? How many electric motors does it take in that power mirror to make the power mirror change axis?
2.
They have 2. And they got to have 2 different.
Oh, I was right.
Yeah, two motors. That's all it takes. It's anchored. You got one for horizontal. You know how when you aim headlights, you've only got 2 screws to do that with typically. That's the same deal. Okay, so that's true. Most vehicles today contain one powerful onboard computer.
True.
Well, that's not really true because you got a lot of onboard computers, typically, right? I mean, a lot of them. Some of them will have, you can have from 20 to 100 onboard computers on some vehicles, and that kind of thing. So just always remember that you're going to have lots of computers on there. How many computers do you think the Crown Victoria has on it? That old 98 Crown Victoria police car we got. It's got 2. One of them controls all the lights. One of them controls the engine. The thing you could actually define as a computer. The lighting control module. Hey, Brian, stand up. See that thing on the right with the white connector on it? Far right. That's it. Pull it out of there. That is a lighting control module, and that computer, you can talk to it with a scan tool. That's on the Crown Victorias and Lincolns and stuff. You got that module that's if you're sitting down in the car, it's right in front of your right knee and above your shin when you got your foot on the gas pedal. That's where that thing's located. And your turn signals and all kinds of stuff goes through that thing. Pretty important, right? Okay, how many computers does the Ranger have on it? The 98 Ranger.
8.
He's pulling that out of his hat. It's got the PCM, it's got the GEM module, it's got the airbag module, which is actually a computer too. So the airbag control module is a computer. So you got 3 computers on that one. You got me? The 3 of them on there.
It keeps saying ABS.
Yeah, that's because you got an ABS problem.
That truck has been acting really weird.
Yeah.
Past couple months.
Is that which one? Your diesel?
Yeah, they're really weird.
That diesel is it's a hoss of a truck and everything, and it's real strong and all that. But whenever it breaks down, you better get your checkbook out. Okay. All right. That's about like it is with any of them now, though. The use of automatic passive restraint systems is federally mandated on all passenger vehicles sold in the United States after 1990. What's automatic passive restraint? What's passive mean? You ain't got to do nothing, right? Automatic and passive would be pretty much the same thing, right? Like on an automatic transmission, you have to put it in drive, but when you take off, it shifts all the gears for you. Is that right? On a passive restraint, you basically have something in the steering wheel that pops out like a pillow and your face hits it if you crash, right? Now, they also were putting automatic seat belts. You ever been in a car with automatic seat belts?
Yeah.
Once.
Don't you hate them darn things?
Sit down.
Damn.
Well, fuck, I liked it.
When I
Yeah.
had longer hair, I had a catch in my hair.
Was that good?
I liked it.
Huh?
I liked it.
Yeah, it's okay. My wife used to gripe because she had that little Ford Tempo that I bought her brand new. It had one, and it was a 93 model, and it would always grab a hold of her purse, and she'd fight with it, and she just had a terrible time with that darn thing. But nowadays, you buckle your seat belts, but everything else. Now, the Sonata that we got out there has got airbags all the way around the, it's got airbags in the seat, it's got airbags up here, it's got airbags. So if you crash, no matter which way you happen to be swinging your head, whenever the car's rolling over, you're bouncing off of soft airbags. And it kind of keeps you from getting hurt very bad. That's what that's all about. If you had a head-on collision between a 2009 model Chevrolet like a Impala, and a 59 model Chevrolet Biscayne, who do you think would win?
59.
Actually, it loses in a big way because they weren't making cars as safe back then as they are now. There's actually, if you want to go to YouTube, there's a YouTube video of them running a 2009 model with, with crash dummies in both of them. They're running them together at 45 miles an hour head on, I think it is. And the crash dummy in the 59 model is killed, just chops him all up. The other guy has no significant injuries because the way cars are made now, they accordion and they have airbags and they have all kinds of stiffening, and they protect the occupant a whole lot better than the older cars did. So just keep that in mind. I mean, the newer the car gets, typically the safer it is. Okay.
On Facebook one time with an old car, people so somehow they got in the wreck. This lady just went flying in there.
Yeah. Yeah, well, they didn't have seatbelts in them. Seatbelts weren't mandatory, I think, until 1965. And so if you ain't wearing a seatbelt, you're going out of there. And you hear people that you read. I've been reading about people in the newspaper that getting killed in car crashes here lately, and it says in the newspaper article they weren't wearing their seatbelt.
I've heard of people getting decapitated by their seatbelt.
Yeah, that's possible. Everything's off the table. But I will tell you this: you can actually you're going to do a whole lot better with the seatbelt. What am I trying to say? With a seatbelt on, it keeps you in the seat and control the car. And a lot of times, if you're wearing a seatbelt, it prevents an accident from happening. I knew this girl that wasn't wearing a seatbelt on a Bronco, or a big Chevrolet Blazer, and she accidentally, some stuff started to slide off the seat. And this is a girl that I knew. And she went to lean over to get the stuff off the seat, and she got over into some rough dirt on the side of the road, and that Blazer started doing this, and it threw her out of the driver's seat over into the passenger seat. And she started trying to reach over there and hit the brake with her left foot, and she hit the gas. And she picked up speed, and the truck flipped over end. Didn't hurt her all that bad, but her mother says because it caved the driver's side of the truck in, they said, oh, if she'd been wearing her seatbelt, it would have killed her. And I said, no, if she'd been wearing her seatbelt, she wouldn't have had the wreck. Because if you listen to what she says, as soon as she started hitting those bumps, it threw her out of the seat. And now nobody's driving the car. See what I mean? Are you safer with somebody driving the car or with nobody driving the car? That's what seatbelts are good for. And I've been wearing mine religiously ever since the first time I got a car with a seatbelt in it. It's just really a good idea to always wear your seatbelt. Tires are not involved with any computer system.
Skip 9.
I'm going to say, they're acting like, oh, did I skip 9? The Ford Model T was the first people's car. It was. And you could get it in any color you wanted as long as it was black. Okay. Tires are not involved with any computer system. And this one out here, the answer key claims, I'm serious. Those Model Ts, the Ford cars, Henry Ford always wanted them to be black. He thought every car should be black. He did not like cars of all different colors. He liked the shiny black cars. Now, how did they paint those cars?
The lead.
They painted them with a brush, and then they polished the brush marks out. But anyway, tires are not involved with any computer system. I'm gonna say that's false because you got tire pressure monitor now. You got me? Make sure you put false on that one because that is a false premise. Alternate propulsion vehicle systems may include all of the following except what? Fuel cell vehicles, hybrid vehicles, hydroelectric vehicles, or electric vehicles.
Maybe hydro.
Well, what about, it says they include all of the following except, pay attention to the except thing there, Curtis. You got hydroelectric. You ever heard of a hydroelectric vehicle?
No.
What the Sam Hill is hydroelectric? You heard that word before?
A hybrid speedboat, maybe?
Well, what are you talking about when you think hydroelectric power?
Maybe something like a Batmobile?
They're talking about the dam, where they dam up a lake and they have a turbine in there and all that. That's what makes hydroelectric power. If you know the answer, say the answer. You're right. Your wheels were turning. You knew what I was talking about. Okay. Don't be bashful. Okay.
I'm not.
All right. Technician A says most manufacturers network their electrical system through computers. We talked about that earlier. Technician B says a networked system. In a network system, a fault in one component may cause several symptoms. Who's right about that? Both of those guys are right, yep. That's what I was talking about before. Number 13, the principle that the automotive horn operates by is what? How does a horn work?
Frequency modulated.
No, it's electromagnetism. And here's how you troubleshoot a horn. This is going to sound simple as dirt, but let's say that you draw a work order that the horn doesn't work. I mean, whenever I was working at the dealership, I did a lot of electrical work and, computer work and all that stuff and engine performance and all that kind of thing. But anyway, whenever they say if the horn doesn't work, and this is the rule of thumb, you always check the easiest thing first. I mean, the first thing, does the horn have a fuse? Let's see if the horn's got a fuse. If the horn's got a fuse, you check the fuse. If the fuse is okay, I'm going to get under there at the horn with my test light, and I'm going to go into that. I'm going to hook your test light in the ground and make sure you got a good connection so the test light will work. If you got a test light that won't work, like somebody in here who shall remain nameless the other day hooked a test light to the rubber part of the battery cable. Who was it that did that?
Probably her.
No, it was you.
I don't remember this.
No, well, me and Adam went out there and out to that truck that you were looking at for the fuel pump, the red one. And I says, okay, the test light's supposed to be hooked up over there. And we noticed that the test light was hooked to the rubber part of the battery terminal where it wasn't even touching any
Well, it
metal.
wasn't finished. I mean, I walked away.
I'm just giving you a hard time, but it was funny. All right. But anyway, don't worry about that. But, don't throw it off on her, because she's not the one that did it. All right. I wouldn't have said you if you hadn't have accused her. I wouldn't have pointed the finger at you. Okay. All right. But anyway, this is what I'm going to do. I'm going to take my test light. I'm going to hook it to ground, and I'm going to make doggone sure I got a good ground by touching it to the positive battery terminal. And then I'm going to go to the wire that feeds the horn. I got to find the horn first. Naturally, you got to go where the horn is. And then I'm going to go into that wire that feeds the horn, and I'm going to tell my buddy, Joe, mash the horn. And so he mashes the horn. If that light lights up, what do I know? You've probably got a bad horn. All right, now, here's my other rule of thumb. I always tell you this. The component that's in the most hostile environment that's working the hardest is usually the one that fails. That make sense? If you've got a system that's got several components and you've got one component that's in a hostile environment that's working really hard, if it has to deal with heat and cold a lot or vibration or mud, and I mean, that's the one I'm going to suspect first. And the horn is the hardest working component in the horn system in the most hostile environment. And of course, then you go back, if you don't have power, you got to go check your relays and your horn switch and all that kind of hogwash. Clock spring, that kind of thing on them. Okay. The seat recall position on most memory seat systems is only allowed if what?
Transmission is in park.
Exactly, if the transmission is in park. How does that work? We're talking automotive electronics here. Tell me how the memory seat works. Think about that. I mean, think about this. When I'm looking at something like that, I want to know if I was an engineer and I had to come up with a way for this thing to remember where that seat was and put it back in the same place.
I'd imagine possibly something that has to do with resistance.
Sort of, but you remember when I showed you guys the scope pattern on the fuel pump? You remember the little bumps? Mm-hmm. It counts those. Is what it does. And so what it does is when you set it, this is where I want it to be, that little module or the body computer or whatever's looking at that is going to look at those little bumps on that motor coming, all of the motors. It's going to watch them all. And it's going to say, what happens is when you set that thing, the algorithm is typed so that is 0 on every motor. If you got more than one motor, if you got a motor for go up and back, whatever. Whenever it starts moving in one direction, it's going to go 1, 2, 3, 4, 5, 6, 7, 8. It's going to remember, it was 8 that he went this way. And this one went 1, 2, 3, 4. All right, when you get back in there, if you hit the fob for mama's key, then it's going to go 4 this way and 8 that way, and it's going to put it right back where 0 was. You understand how that works now? Not that complicated, really, when you think about it. And so basically, it's going to count the little humps. Because that's already there. You don't have to add a sensor. You just have to add a microprocessor that's intelligent enough to count those little ripples. And it's got to have sensitivity. I mean, somebody had to be pretty smart to come up with that, but that's the way they do it. Okay. Let me see, Technician A says the neutral safety switch is used on vehicles with automatic transmissions, which is true. Technician B says the neutral safety switch is used on vehicles with manual transmissions, which is true. That's been around for a pretty good while. In the early 80s, there were vehicles that did not have neutral safety switches on them, and if you started that thing in gear, it was gone. Poof, run into something. And it's really smart to have neutral safety switch on a vehicle. Here's something else I want to caution everybody about when you're working on electronic stuff, and I've preached this over and over again every time I teach a class. There's some things that you absolutely do not need to modify as far as the way that the wiring is done or anything like that. One of the things you don't need to modify is cruise control. Don't need to modify it. Keep it like it was, exactly the way it was. Same components, same wiring and all that. Now you may have to splice a wire or something like that. But there was a car that had a cruise control that wouldn't work on it. It's looking at a ground that comes through the stoplight bulbs to determine if you've hit the brake or not. And there was this person that put a LED lights on the back of their Ford Focus, and the cruise wouldn't work anymore because and somebody said, well, I can just, put something back here so that there'll be a ground coming through there and the cruise will work. And if you start modifying stuff like that, and then the cruise doesn't cancel and they run into somebody, and you modified it, see what I'm saying? Here's something else, airbags. Leave the airbags like they are. The passive restraints. Don't do anything with that. It's going to, use your common sense. There's a lot of stuff you don't need to modify like that. Okay, let me see. Vehicles equipped with automatic traction control systems do what?
D.
That's going to be D. It automatically applies the brakes to the wheel that's spinning. Number 17. Now the reason it does that is so that the drive line will send some torque to the other wheel, and the car will pull off. All of the following statements about an airbag system are true except A, deployment is automatic. That's true. B, it's a supplemental system. That's true. C, it's mandated by the federal government. That's true. D, it's an active system. What does it mean if it's an active system? It means you got to do something to make it work. Active system, it is not. So that on number 17 is going to be D. We're almost through here. Technician A says most manufacturers now use a system of vehicle communications called multiplexing. That's true. Technician B says multiplexing allows control modules to share information. That's true too. And the purpose of the vehicle multiplex system is this is what I was talking about earlier in the class. You can take information from one computer, like engine coolant temperature, vehicle speed, whatever, and use it where other computers need that. So number 19 is going to be A, you got to allow computers to share information. Finally, number 20, all of the following are true of the easy exit feature of memory seat systems, except A, the system may move the steering wheel up. B, it's an additional function on memory seat systems. C, the driver's door is opened automatically. D, the seat's moved all the way down and back when the vehicle is placed in park. That's basically C is going to be the except on that. It's not going to open the driver's door. Now, the 66 Thunderbird, you guys ever seen a 66 Thunderbird?
No.
The 66 Thunderbird, have you ever sat down in one and looked at what it looks like on the inside? Looks like a dadgum rocket ship in there. And when you take it and switch it off and put it in park, the steering wheel suddenly unlocks and it slides over to the right so you can get out of the way. So do you ever get hung up on a steering wheel when you're getting out? You do, Quincy? What about you, Curtis? You get hung up on a steering wheel when you're getting out?
Sometimes.
You don't want to talk about that, do you?
The only reason I do is the seat's so far up.
Huh?
The only reason I do is because the seat's so far up.
Yeah.
Well.
Well, Well, anyway, all those little Thunderbirds, you could slide the steering wheel all the way to the right. You had lots of room to get out. You know, it was pretty cool how that was. But anyway, that pretty well concludes that.